All right, 7.6, law of sines. There are actually two different laws we're going to learn. We're going to learn law of sines today, law of cosines on Tuesday. The law of sines introduces the idea that trigonometry can be used outside of right angle. It is based on right angle, so we're going to look at the proof of this. But the concept here is that for any triangle, not just a right triangle, there is a ratio that happens between your sides and your trig functions of those sides. And the law of sines is the first one. What you need to be aware of is when they have a capital A, they are talking about the angle A. When they have a lowercase a, they are talking about the side opposite of the angle A. All right, so it is important that when you're talking about sine of A over A, they mean the side opposite of that angle. The ratio that occurs is that the sine of A over A will equal the sine of B over side B, which will equal the sine of C over side C. So this helps you solve for triangles and solve for sides and angles when you have only part of them. Part of them when you can't use Pythagorean theorem, right? Or it's not a right triangle and you can't just use SOHCAHTOA. This will then help you solve for a triangle. Look at the proof a little bit. It's based on a right triangle. So they have the SOHCAHTOA. So this would be sine of A is going to be opposite over hypotenuse. Sine of B is going to be opposite over hypotenuse. And then when they solve for H, so if we were to set this up, just based on this right triangle here, the sine of A, this would be opposite of A, and this would be the hypotenuse for that triangle on the left, right? That is going to be H over B, right? And then the sine of B, if we were going to look at that guy, sine of B, this is opposite for B, and this is hypotenuse for B, for that right triangle. So this would be H over A.
Could you also do sine?
All right. And so then when I solve for H over here, I get that H equals sine of A times B, right? And when I solve for H over here, I get that sine of B times A equals H. All right, so I have those going on. I'm going to move this up a little. And so then if they both equal H, then that means they equal each other. So that means sine of A times B equals sine of B times A. So when I put A's together and B's together, I would divide both sides by A here to get rid of him. That's divided by A. And I would divide both sides by B to get that over here. So that means that sine of A over A equals sine of B over B. And that's where we get this theorem from, okay? Let's look at this. It says find B, round it to the nearest tenth, all right? Find B. So we have angle A, side A. Angle B, we need side B. This is not a right triangle, all right? So we're going to set it up with our ratios. Sine of A, sine of 37 degrees over side A, 3, equals sine of B, 68 degrees over side B. That's what we're looking for. All right. So now when you have something like this, by the way, you can reciprocate both sides. So when what you're looking for is in the denominator position, you can reciprocate both sides. So I can say, I can flip both of these. I can reciprocate them both. 3 over sine 37 equals B over sine 68. So how do I solve for B? How do I solve for B? It's B divided by, so what do I need to do? Yeah, you can cross multiply. So you can just do times the sine of 68 here. I'm going to show you two ways to do this, sine of 68. So you end up with 3 times the sine of 68 divided by the sine of 37. If you didn't want to reciprocate it, you can cross multiply with just your ratios like we did for bell work. You can say B times the sine of 37 equals 3 times the sine of 68, and then divide both sides by sine of 37. Either way you do it, you're going to get 3 times the sine of 68 divided by the sine of 37. And when you do that, rounded to the nearest tenth, you will get 4.6. So first, make sure in your calculators that when you do that, you get 4.6. Look at the second example here. Find the measure of z to the nearest degree if xy in xyz, if y is 17, z is 14, and the measure of y is 92. They did not give us a triangle. So we are going to draw a triangle so that we know what we're doing here. All right, so we have triangle xyz. All right, so we're going to draw our triangle. It does not matter what the triangle looks like as long as you know this is not a right triangle. Okay? All right, and you're going to label it x, y, and z. All right? Y. Side y is going to be opposite angle y. Side z is going to be opposite angle z. And the measure of y is going to follow where y is, 92 degrees. All right? They want specifically the measure of z. So we are looking for this angle right here. All right? We're going to use law of sines. So sine of y, 92 degrees, over y, 17, equals sine of z over side z. All right? We can use cross multiplication again. So 14 times the sine of 92 degrees equals 17 times the sine of z. How do we solve this guy? How do I solve for sine? Divide by my 17, right? Now, 14 times the sine of 92 degrees over 17 equals the sine of z. We want z. What do we need to do when we're solving for the angle?
Inverse.
So I need to do the, and technically you're doing the inverse of both sides, by the way. So the inverse sine here cancels out with the sine and you're left with the z. The inverse of the sine of that will equal z. All right. Listen in your calculators. Let's talk in your calculators. All right. Let's move them. Why is it not moving? There we go. Let's move them over. All right. So in your calculators, you're going to do the sine inverse button. So that's your shift sign. Then you're going to say 14 times sine 92. Make sure you close that parentheses. Divided by 17. Close parentheses again. And you should get approximately what? 55. And it said to the nearest degree. So pay attention, nearest degree, 55 degrees is what you get there. All right, solving a triangle. What does it mean to solve a triangle? When they say solve a triangle, it means they want every single side measurement and every single angle measurement, all right? So when you solve a triangle, no matter what they've given you, this is what I want it to look like on your paper. This is triangle ABC. So I want you to say angle A, angle B, angle C, and then side A, side B, side C, okay? This is what I want it to look like. Then you're going to fill in what they have given you. They told you the measure of angle A was 33 degrees. They told you the measure of angle B was 47 degrees. We are going to look for the measure of angle C. They told us the side length of B was 14. Now, there's an easy way to solve for the degree measurement of C. What is it?
The 180.
So they should all add up to 180. So 180 minus 33 plus 47. What's 33 plus 47? 80. So that means the measure of angle C is 80 degrees. That was an easy one. I mean 100 degrees, right? 100 minus 180 minus 80. All right, so now we can use law of sines to solve for our other ones. The only two sides that I have, the only two letters, I mean, the only letter that has both things, angles and side, is B. So I have to start with that guy. All right, so I'm going to start with B here. And I'm going to say the sine of B over 14 equals the sine of A, which is 33, over side A. Now here's what you don't want to do. You're going to get a decimal somewhere for side A. Go back to B to do C, because you have rounded already in that answer. So we're also going to do the sine of B, which is 47 degrees, over B equals the sine of C, 100 degrees, over C. So you're going to solve for both of these, and you're going to complete your triangle by this. Cross multiplication. So A times the sine of 47 equals 14 times the sine of 33. So A is going to equal 14 times the sine of 33 divided by the sine of 47. Same thing here. C times the sine of 47 equals 14 times the sine of 100. So C is going to equal 14 sine 100 divided by sine 47. And when you put all of those into your calculator, in this particular case, they wanted us to round to one decimal place. One decimal place. So when we solve for A to one decimal place, when you do all of that, you should get 10.4. That will fill in the 10.4. When you do C, you should get the 18.9.
Would you get the same answer if you...
All right, solve the triangle ABC, and they give us the measurement of C and two sides, the measurement of C and two sides. So once again, I'm going to say, well, I need the measure of A, I need the measure of B, they gave me the measure of C. I need the length of A, they gave me the length of B, and they gave me the length of C, okay? And so I'm going to use the same concept. Sine of C over C equals sine of B over B. All right? Once again, I am going to have to use my inverse sign here, right? So if I multiply both sides by that 14, then my sine of B will equal this guy. So I need to use inverse sine of this whole little thing here. All right, makes sense? 44 degrees. All right, that is what B equals. B equals 44. Once I have B, what do you think I'm going to do to solve for A?
You add them up and subtract by 1.
Right, so once I have that, I'm not going to go back to sine of this over sine of that equals that. I am going to just subtract from 180. And so when I do 44 plus 98 subtracted from 180, I will get 38 degrees. All right, 38 degrees. Because path of least resistance is really what you want to do with these. Now that I have the 38, I will have to use my law of sines again. And I always go back to the one that was given to me because I have somewhere probably rounded in this. And so once again, I'm going to say sine of C over C equals sine of A over A. And do the same thing, right? Cross multiplication. So A times the sine of 98 equals 20 times the sine of 38 divide. So A will equal 20 times the sine of 38 over the sine of 98, which is going to give me 12.4 when I put that in my calculator. And so this is what solving a triangle looks like. When you have all parts of the triangle completed, then you have solved the triangle. All right. So just to walk through, they gave me the measure of P, the angle P, the measure of side P, and the measure of side R. So I used my sine of P over P equals sine of R over R. Because I was solving for the R, I had to use my inverse trig function between the multiplication of these and then divided, 19. Once I plugged in 19, 180 minus those two gave me my 56, and then I could use law of sines again. Sine of 105 over 32, my P, equals sine of 556, my Q over Q. And here I just had to do cross multiplication with my sine functions to get that guy. All right, last one. Indirect measure. When the angle of elevation to the sun is 62 degrees, angle of elevation to the sun, that's from the ground up, is 62 degrees. A telephone pole tilted at an angle of 7 degrees. 7 degrees. It's tilted at an angle of 7 degrees. That means that it's going from 90, 7 degrees this way. All right? From 90, 7 degrees this way. So if it started at 90 and it shifted 7 degrees, what is the new angle measure here? 83 degrees. 83 degrees. Find the length of the telephone pole. All right? Length of the telephone pole. All right? So they want this length right here. So basically what we have is we have this triangle. All right? Here we have the tilted telephone pole here, right? It's probably more like that, all right? And it cast a 30-foot shadow. You can tell I'm not on my straight line there, all right? So we have a 30-foot shadow, all right? We have an angle of elevation from the ground up to be 62 degrees. And because our telephone pole tilted 7 degrees, we have an 83 degree here, all right? They want the length of this guy, all right? I need a side and the angle opposite that side. I don't have the angle opposite the side, but I can easily solve for it. How do I do that? Yeah, so 180 minus 62 plus 83, or that gives me what? 35. All right, so this guy is 35. Easy enough. I'm going to use the law of sines, okay? Law of sines here. Sine of 35 over the 30-foot shadow should equal sine of 62 over the height of my pole. All right? Cross multiplication will solve it for me. Sine of 35 times x equals sine of 62 times 30. Final step here is to divide by sine of 35. So when I put that in, sine of 62 times 30 divided by the sine of 35 equals what? And it wants it to the nearest one decimal. So 46.2 feet is how tall that guy is.
It's a lot easier.
The law of sines can be used to solve a triangle in the following cases. You know the measure of two angles and any side of the angle. Look what they referenced. Angle, angle, side, or angle, side, angle. You know the measures of two sides and an angle opposite one of the sides. All right? This is not a theorem, but it doesn't matter what you have. As long as you have at least one side and the angle opposite that side, you can solve that triangle with the other things that you have, okay? At least one side and one angle opposite that side, and you have one other piece of information in that entire triangle, you can solve it. All right, that's what you need to remember.